Well, a very good afternoon, everyone. Welcome to week 4 of the semester, and I hope all of you are doing well. And also, I hope that you're staying safe so far. Now, this week we have few things that we'll definitely look onto. Good afternoon, Shannon. Thank you. Uh, we have these things in line for the week. Okay, so we have a Zoom-based lecture class that you're attending to at the moment. Moreover, you have a lecture-based quiz. This is week 4 lecture-based quiz. You should be able to find within the week 4 section of the Moodle shell. And then you have to attempt your tutorial questions. The tutorial questions are also on the week 4 section of the Moodle shell. Please do make an effort to attempt this before our tutorial class. This is on Thursday. You have ample time to attempt it. And also, you have to attempt a lab exercise. In fact, there will be 2 lab exercises, which I will be giving out to you in the class. We'll attempt one of it together, and the other one, you'll have to do it on your own. And then finally, participate in the tutorial discussion session. These on Thursday. Now, those are the tasks for week 4. Okay, moreover, some more things to note is that, okay, your mid-semester exam is coming up within 3 weeks time. This is week 4, week 5, week 6. That means you have only 2 more weeks to prepare, and week 7 your mid-semester quiz will be up on Moodle. Furthermore, just a reminder, your lecture quizzes, which are based on each and every lecture 1, lecture 2, lecture 3, is already there, and we have lecture 4 as well, which has come up today. Now please do make an effort to attempt it. Now at the moment, there's less than half of you who have not actually attempted the lecture quiz. So just a reminder, I know the due date is right at the 31st of October, but try to attempt it as soon as you are done with the lectures, your lecture discussion and tutorial discussions. So that will make you way more easier, since things will still be fresh in your mind to actually go and attempt your online quiz. Apart from that, your assignment, most likely your assignment, which is in the form of a project, will be out by late this week or early next week. So I will try my best to get it up online a weekend or early next Monday, so that you will have ample time to work on to. It will be group based. So yeah, so that's all I have in terms of reminders. Now, if I'm missing on to anything, or if you have any questions or queries, feel free to ask. I'll give you 2 more minutes to ask questions. And if you have any queries, you can also ask. You can probably unmute your mics and speak. Or another thing you could do is you could basically drop a message with the use of the chat feature available in Zoom. So you have 2 minutes. And after that, we'll quickly hop in and we'll discuss our lecture notes. Today, we have quite a lot of slides in our lecture notes. So floor is open for any questions or any queries. No questions, no queries? Okay, if not, let's not waste time. And let's begin with our lecture notes. Now, this week's lecture note is derived from chapter 4 from the textbook System Analysis and Design NAN edition by Shelley Cashman series. Okay, and we'll be looking at requirement modeling. Now, requirement modeling is an essential part of any systems development, and you may find requirements modeling generally within the system analysis phase of the system development lifecycle. So you have, first of all, the very first stage, you have basically you start with preliminary investigation, and there onwards you have system analysis, which is your next phase. Now within that, you have something called as requirements modeling. Now, requirements modeling is basically a process. Sorry, it's a process used in software development project where requirements and solutions constantly evolve through collaborative efforts and teamwork. In simple terms, what happens is whereby you have new requirements and solutions coming up through the use of collaborative efforts and teamwork. Collaborative efforts is more likely where you come together, more than one individual, you come together and then you try to come up with solutions for your requirements. So this is what we will be looking at in this week's lecture. Now, your chapter objectives, or in our case, lecture objectives, describe system analysis phase activities. We'll go around describing the activities that take place within systems analysis. Moreover, we'll go around explaining JAD and RAD. The long form for the abbreviation JAD is Joint Application Development, and RAD is Rapid Application Development, and we also have Agile method. And then we'll go around looking at some of the models. So we have some models which defines business processes and business functions. And these models may be in terms of data flow diagrams and use case modeling. And then finally, we'll list and describe system requirements, including outputs, inputs, processes, performance, and control. So we're looking at the requirements for all these within a project through the use of output, inputs, processes, performance, and controls. Moreover, we'll go around looking at some fact-finding techniques. Now, last week we did go over some fact-finding techniques, very basic ones, and the same will be used here as well. But over here, it will be detailed. And much more in depth. And then we'll go around defining total cost of ownership and what it is, and what are the things we should note when we are defining the total cost of ownership. Moreover, we'll look at what are some of the conducts while performing a successful interview, and then finally develop effective documentation methods to use during systems development. So we'll be looking at all these, and these are our key objectives for this lecture. Now, objectives play a very big role in our lecture notes, because generally when we prepare examinations, when we prepare quizzes, when we prepare questions for your exams, generally we try to ensure that we are meeting these objectives. So in other words, when you are looking at the lecture notes, by the end of the lecture, you should be able to describe these objectives. If you're able to do so, then you're on the right track. If not, you might need to go and look into the lecture notes and those terms once again. Now, slide number 4, systems analysis phase overview. The overall objective of the systems analysis phase is to understand the proposed project, ensure that it will support business requirements, and build a solid foundation for systems development. You use models and other documentation tools to visualize and describe the proposed system. So in system analysis phase, the major purpose is for the systems development team is to understand the project. And to understand the project, they will also need to ensure that the project will support all business requirements. Moreover, they are to ensure that they are able to build a solid foundation for the system development. Okay, now how to do that? How do they do that in the system analysis phase? Generally, it is done through the use of models and visualization or documentation tools. So this is what all happens in systems analysis phase. Now, system analysis phase overview. System analysis activities. You have requirements modeling, outputs, input, process, performance, security. So this is all what is generally included within the requirements modeling. Now, just to ensure you and to let you know once again, you have system analysis. So within system analysis, one of the activities is requirements modeling, and it is an important one. Now, within requirements modeling, you have outputs, you have inputs, processes, performance, and security. So if we end up defining a requirement model, basically it involves fact finding to describe the current system and the identification of the new requirements for the new or the upcoming system. So what happens is generally now when you are trying to create a new information system or develop a new information system rather, so what you will do is you'll go and do all the possible fact findings about the current system which is in the organization, and then from there onwards look into the files and try to identify the requirements for the new system. So this particular requirement model allows you to do so. So what you end up doing is you'll go and look for the output, the input, process, performance, and security. Instead of security, sometimes they would say controls. It means the same thing. So you'll go and look at all these 5 features of the old system, and then you'll try to identify if there are any gaps or if there are any faults. If so, then within the new system design phase, you will try to ensure that all these faults or gaps are properly catered for. System analysis skills. Now, you basically need 2 major types of skills, okay, when you are doing system analysis, and those are analytical skills and interpersonal skills. When you talk about analytical skills, so we are talking about ability to deconstruct information into smaller categories in order to draw conclusion. So you break down the information into smaller pieces and then try to make a conclusion out of it. In other words, what you do is you collect data and then you try to evaluate data, you try to break it down and then look what are the problems, what are the benefits, what are the issues, and then based on that, you draw necessary conclusions. So that is an example of an analytical skill. And finally, you have interpersonal skill. Interpersonal skill is the ability to communicate or interact well with other people. Now, this becomes very handy. Why? Because generally when you go around collecting information to make a necessary conclusion, you'll have to talk to people, you have to talk to the users or any other related stakeholder. So based on that, your ability to communicate with people or you having the interpersonal skills is very, very important. Now, team-oriented methods and techniques. So we have 3 techniques and methods, which are basically team-oriented. That means you have to deal with teams, or teams are generally constructed to do so. We have JED, RED, and Agile development. And we'll learn more about these 3 techniques in the next few slides. So first of all, we're looking at JED, Joint Application Development. So JED is basically user involvement. Users have a vital stake in an information system, and they should participate fully. When we say stake, that means they have interests in an information system and they should participate fully. Successful systems must be user-oriented and users need to be involved. One popular strategy for user involvement in JED, one popular strategy for user involvement is a JED team approach. So in simple terms, when you're talking about JED, you are generally talking about user involvement. You have active user participation in this method and technique. It's more likely user-oriented or more of user involvement. And it is a team approach, okay? Now, what happens in JED is basically the user is put into the center of attention. So everything happens from the user's point of view. In other words, what we say is we will try to develop the system from the user's point of view or from the eyes of the user, okay? And the biggest stakeholder in JED application in JED development is basically the user. Why? Because they are the ones who will be using the system and they're involved in each and every phase of the development. And then we have the roles of the participants in JED. So you have a project leader, develops an agenda, acts as a facilitator. When you talk about a facilitator, the person who leads everything and leads the JED session. Top management provides enterprise level authorization and support for the project. You have managers provide departmental or department level support for the project and understanding of how the project must support the business functions and requirements. Users provide operational level input on current operations, desired changes, input and output requirements, user involvement, user interface issues rather, and how the project will support day-to-day tasks. And then you have system analysis and other IT staff members provide technical assistance and resources for JED team members on issues such as security, backup, hardware, software, and network capability. And then you have recorder, documents results of JED sessions, and the works with the system analysis to build system models and develop case tool documentation. So these are some of the JED participants. So you have the project leader, the person who leads the project. You have top management, basically people who are sitting at the strategic level. So what happens is generally they are the main point of liaison between the project leader and as a business. Why? Because they need to ensure that the project is run as per the strategic plan. And then you have managers. So these managers are someone who exists at the middle level, and they actually are the communication between the users, the middle level managers, and the project leader. And then you have systems analysts and other IT staff members. So these are the technical people who basically provide technical assistance and more likely with the hardware and software based assistance within the project. And then you have recorder. Now the recorder is basically an individual, it's not a machine, it is an individual. And what this person does is basically, it may be a person or people, maybe more than one. What they would do is they will record all the JED sessions, and they will work consistently with the system analysis to ensure the system is built as per the JED team meetings. Now, joint application development continued. We will look at the advantages and disadvantages. Now, JED is more expensive and can be cumbersome if the project group is too relative to the size of the project. Allows key users to participate effectively. When appropriately used, JED can result in a more accurate statement of system requirements, a better understanding of common goals, and a stronger commitment to the success of the new system. So if we try to distinguish very carefully between the advantages and disadvantages of JED, when you're talking about the advantages of JED, what it does, it allows key users to participate effectively. So whoever the key users are, they would be allowed to participate more frequently and effectively. Now, when we talk about frequent users of a system, these are those people who use a system on regular basis. So they will have more idea of what things should be and how. Okay. Moreover, some more advantages of JED is that it provides more accurate results. How? Because the users are involved. Better understanding of goals. Now, better understanding of goals. Now, again, JED is more and more beneficial in terms of better understanding of goals, because not only you have the users, you have the management level, and also you have, if you look at your user list, the top management team. So all the three levels within the organization are involved. So it ensures that the project is better meeting the goals. And then there's a stronger commitment to success, since all of them, they are meeting a standard goal or a common goal. So there is better chances for success. And also it's of great motivation. Why it's of great motivation is because if the organization is developing a new system and they are involving their users, their low level, middle level, and high level staffs, all three of them, what happens is that people, especially in the lower ground, those who are operational level staff, who meets day-to-day requirements of a business, they will get more motivated to work and more motivated to build the system better, because they know they will be working with the system. Moreover, they know the organization is involving them in key decision-making processes. So there's greater motivation. Disadvantages. When we talk about disadvantages, generally, JED is expensive. Why it's expensive? Because it involves a lot of people. Okay, just because there are more participants, okay, what happens is that the level of scope is also more. So in that way, in that case, what happens, the overall project, the cost of it increases, the time frame in which it is met also increases. Why? More people comes up with more requirements with more resources being taken in, and it becomes cumbersome. So when you talk about the word cumbersome, cumbersome means something that is large, something that is heavy, something that may be slow, or something that may be very, very complicated. So it's cumbersome because the group of users will be too large. Now, when it is an organization with about 10 to 50 staffs, it's quite easy. It's not that difficult. But what if we have organization, let's say, for example, FNU has more than about 3 to 4,000 staffs. So if you involve 3 to 4,000 users in a project, what happened? It's very difficult to manage everything. Okay. Now, just because of that, just because the group may be too large, sometimes you may have people management issues or arguments, or or it and it may lead to slow reach to a concrete point. That means the ideas may not be given out properly. Okay, or people may not realize that your idea is quite better compared to somebody else's. So these are some of the issues. You know what happens when you have a lot of people involved in decision making process. So just because of that, there may be different ideas and views, and overall the people management issue comes up. So that would be some of the disadvantages of JED. Now next up, we talk about RAD. The long form for RAD is rapid application development. It is a team-based technique that speeds up information systems development and produces a functional information system. Relies heavily on prototyping and user involvement. Interactive process continues until the system is completely developed and users are satisfied. So in simple terms, when you talk about RAD, it is a team-based approach. Okay. Now, what also it does, it relies heavily on user involvement and prototype. So this is where JED goes very different from RAD. In JED, you only have user involvement, but in RAD, you have user involvement, but together with that, you have prototyping. Now, what is prototype? It's just like making models first. Like a prototype would be making a miniature version of the actual system. All right. So there is a difference. Now, also, RAD is more of a iterative process. When you talk about iterative, that means it continues, it rotates, it keeps on overlapping until the system is completely developed or until the users are completely satisfied. Okay, it is a iterative process. For example, in the next slide, what you will see is this is what iterative process would look like. You have requirements planning. So what happens in requirement planning? The tasks are listed. In red, users, managers, and IT staff agree upon business needs, scope, and systems requirement, and then they will obtain approval to continue. So let's say they are given the approval. After that, they'll start developing the user design. So the task is interact with users, build models and prototypes, conduct intensive JED type sessions. Now, these intensive JED type sessions would be is once they are made with a prototype, they'll go and test it out, and then they'll get feedback from all the users who will be involved in the system development. See, after the design is being given a green light, then comes the construction phase. So in the construction phase, whereby these models will be actually be built into a physical system. So program and application development, coding, unit integration, and system testing. So from there, it goes to cutover. Now cutover tasks, data conversion, full-scale testing, system changeover, user training. Now, before it goes to cutover, what you'll see is these arrows. Now, what are these arrows? Now, these arrows indicate there might be a more of a recycling or more of a repetition mode. Now, why we say repetition mode? Because RAD functions as such, we say is iterative. That means it will try to continue its building phase of the system unless and until it is fully completed, until the phase whereby users are completely satisfied. So let's say they build the system, they went around testing it. See, the phase here or the tasks here in construction is system testing. If the users are not satisfied, they'll go around redesigning it and they'll construct. Let's say something went wrong, and then they'll go it over and over again unless and until the users are fully satisfied. Once they are fully satisfied, only then it goes into a phase whereby the new system is replaced by the old system. Sorry, whereby the old system is replaced by the new system within the organization. Okay, that's why we say it's a iterative process, iterative, I-T-E-R-A-T-I-V-E, iterative process. Now, red objectives. Okay, to cut development time and expense by involving the users in every phase of the system development. Successful red team must have IT resources, skills, and management support. Helps a development team design a system that requires a highly interactive or complex user interface. Now, with the red, the objectives are to involve users in every phase of the system development. Now, we know that from the definition. Moreover, what it does, it cuts in the development time and expense. Now, why do we say it cuts in the development time and expense when we actually see it's an iterative process? It's a repetitive process. Now, how it does so? Now, what happens, what it considers here in this term is if you would develop a information system and then later onwards, once it's fully implemented in the organization and only then you know that there are issues with it, it will cost you more and it will consume more time. Remember last week we were talking about this in a tutorial class. So over time, if you would try to evaluate both of these scenario, a red scenario and a normal SDLC scenario whereby it's fully developed and implemented in the organization and then users later onwards find out their issues. So if you try to compare these two scenarios, red would be cheaper in long run. And also it cuts on to the development time, okay? And with red, normally the system is highly interactive. When we say highly interactive, that means the way humans and humans should be able to communicate with the information system, it will be way more easier. So highly interactive and complex user interface. Now, we are saying it's highly interactive. Highly interactive means it's easy to use, okay? And it allows way more interaction with the users, but it says complex user interface. Now, those two are two opposites, right? When we say easy to communicate and then we say complex user interface. Now, why you have complex user interface is this. For example, if I am supposed to make a information system with JED, okay, I'm involving my users, but my interface will be very, very simple. But if I am making with red, I will have complex user interface. Why? Because the users tend to, the system is made once, the users will use it and test it, and then they'll get well versed with it. And it will go through another round of change and then some changes with interface. So over time, the users continuously get well trained with the interface during the repetitive process of redesigning and constructing the system. So that's why they normally have highly interactive and complex user interface. Now, looking at the advantages and disadvantages of red, let's go and read that out first, and then I will explain in simple details what some of the advantages and disadvantages of red may be. Now, systems can be developed more quickly with significant cost savings. Red stresses the mechanics of the system itself and does not emphasize the company's strategic business needs. Might allow less time to develop quality, consistency, and design standards. So the advantages, now some of the advantages of red in simple terms, it's quicker and faster to develop. Why quicker and faster? Because of the repetitive phase, okay, all the possible problems are eliminated while it is being designed and constructed, okay? And the testing code, remember when we say constructing, in the constructing phase, you also have a task called testing. Yeah, system testing. So it goes through so much testing that it becomes easy and faster to develop it. Secondly, it allows significant cost saving. Now we talked about it earlier, okay? Since it goes through a repetitive process, problems and possible bugging issues are identified while it is in the designing and constructing phase. Now, disadvantages. Unfortunately, red has more disadvantages than advantages, okay? Now, what happens is that disadvantages, now red, what it does, it basically starts concentrating on the mechanics of the system. Yeah, mechanics of the system, that means how the system is actually developed or how the system would actually work. it puts so much emphasis on this that it does not put as enough emphasis on the strategic business needs. Remember the strategic goals, long-term goals. So it starts focusing on more on how the system will work rather than the strategic business need. So that may be one of its downfall. Another thing is, if that happens, what happens is that generally it would be of lower quality because it's not meeting the initial purpose. Therefore, it goes through a lesser quality due to the fast development time. Moreover, there's poor consistency and poor design standards overall. Now, also do notice this. With JED, let me just go back. With JED, what happens is that you have the involvement of all these people. With RED, you only have the users with it or with you, and moreover, more prototyping. Okay, so that's why the disadvantage stands as it stresses the mechanics of the system and does not emphasize on the strategic business needs. It's of lesser quality, okay, and it is of lesser consistency and of poor design standard. Agile methods. Agile method, this is another method in which system requirements could be done or modeled. So the second point is the advantage or disadvantage of RED. Do you mean this one? This is a disadvantage. RED stresses on the mechanics of the system itself. What it simply means, it starts to focus so much on the design and the construction of the system that it does not emphasize on the company's strategic business need. So that needs to be created well before the design even. Okay. Now, agile methods attempt to develop a system incrementally. When we talk about incrementally, that means something that increases or progressively. Elegant modeling toolset includes support for many modeling tools. Some agile developers prefer not to use case tools at all and rely instead on whiteboard. Okay, ignore this last portion. Okay, so when we talk about agile development method, we're talking about developing the system incrementally. That means small progress, but in stages. Okay, now what happens in agile development is basically it manages a project by breaking it up into several small pieces. Moreover, it involves constant collaboration with stakeholders. Also, do note that while it performs the tasks in stages, it continuously makes improvement in every stage. So rather than developing the entire system all at once, it divides the system, let's say, in certain parts or in certain stages and tries to complete one step first. So once that stage is completed, then they move on to the next one. So this is what it means. It attempts to develop the system incrementally. The agile method, agile method has a method within it. It's called Scrum. Scrum is a rugby term. Scrum sessions have specific guidelines that emphasize time blocks, interaction, and team-based activities that result in deliverable software. Now, in simple terms, now that becomes very difficult for you to actually define or to understand. So when we talk about Scrum, it is used in the development of a system. Okay, Scrum is just like a methodology, or it's like a framework. When we say methodology or framework, we're talking about a structure. All right, so it's a structure that is used in the development of a system in an iterative and incremental process. In other words, Scrum, okay, it gives you with the structure, it gives you the framework to go and develop the system in iterative. Another word for iterative is repetitive and incremental process. So what you will be doing is, let's say if you are the project team leader, so what you will be leading the project is with the use of agile method, you will develop the system, okay, using a Scrum framework, and you'll be developing it repeatedly and incrementally. That means if something goes wrong, you'll go back and then redo it. But you will try to increase the stage in small portions. Now, agile methods, advantages and disadvantages, are very flexible and efficient in dealing with change. Frequent deliverables constantly validate the project and reduce risk. Team members need a high level of technical and interpersonal skills, may be subject to significant change in scope. Now, when you talk about agile method, the advantages, in simple terms, okay, it is flexible and efficient in dealing with change. Now, why? Because of its nature. So the nature is it does things in an incremental process. That means it tries to gradually develop the project in stages. So what happens is when it tries to develop project in stages, as new change will come in, so the team would be able to cater for the change. Now, change may be in terms of a change in scope, change in technology, change in time frame, and so forth. So the team would be able to cater for it. Moreover, it will have frequent deliverables. Okay, so frequent deliverables means you have different stages. Once you finish one stage, you have a deliverable, you have a final output, and then you go on to the next stage, you have another deliverable in this stage. So that's final output again. So this allows constant validation. That means with frequent deliverables, there's more times whereby the project is being validated. Disadvantages, on the other hand, for agile method is that it requires high level of skills, especially in terms of technical and interpersonal skills. Moreover, it is subject to significant change in scope. So what happens is that since you're making the project in stages, there's a likely chance you have more of scope creep. So scope creep generally leads to you creep in. Creep means that means increase, really leads to creep in time. Your time also needs to increase, your cost also increases, and your budget also increases. And then just because of that, it leads to overall more consumption of resources. Modeling tools and techniques involves graphical methods and non-technical language that represent the system at various stages of development. Can use various tools. So when we talk about modeling tools, okay, these are visual tools that is used to represent a system. So what kind of things does it represent? It will represent the flow of data within the system. It will represent the processes. It will represent the risks within the system. It will represent the benefits, but all of these would be done using visual or graphical tools. Now, there are few graphical tools that which represents these processes and are used in requirement modeling. Okay, so the first one is data flow diagram. So data flow diagram, or DFD, it shows how the system stores, processes, and transforms data. Additional levels of information and detail are depicted in other related DFDs. So data flow diagram, in simple terms, okay, it shows how the data flows within the information system. Now, how does it show? Now, it shows the system, how it stores data, it shows how the system processes data, and it shows how system transforms data from input into output. So that's data flow diagram. And the other model that is used in requirement modeling is use case. Now, use case is definitely one of the important ones and still used till this very day. Okay, so a use case represents how a system interacts with its environment by illustrating the activities that are performed by the users and the system's responses. So use case, again, in simple terms, it is a representation of how the system interacts when activities are performed by a user. So you have two notations in use case. You have a actor and you have events or trigger. Events and trigger, they would mean the same thing. By the way, DFDs and use case diagrams, we will be learning it over our course in this semester in CIN603. So far, we are on PERT chart or critical path charts. After that, we'll go on to Gantt chart, and then we'll look at use case, we'll look at DFD, and then use case. And after use case, you have one more. You have schema data or schema charts, and then you have some mathematical calculations. Systems requirements checklist. System requirements fall into 5 general categories. Okay, so those categories are outputs, inputs, processes, performance, and controls. Typical examples of system requirements for each category are listed below. Now, what happens here is when you're doing a requirements modeling, you have to ensure that you use certain type of methods to actually develop your system. So we have listed the three possible methods you may use. You may use either JED, RED, or Agile. Okay. Now, from there, we've also looked at some of the software tools or modeling tools, not software tools, but modeling tools that you will use to actually put in your requirements. So you've looked at DFD and use case. Now, the next thing that we'll be doing in requirement modeling is basically we'll go and perform a checklist of all the things that the system may require. So when you're looking at the checklist, you're going to look at 5 categories. You're looking at, okay, whether your system would meet the output, the desired output, the input, processes, performance, or security. So we will be reading those examples. Now, output, now what example it is listed here is for a web-based system. So we'll go and see what the outputs, the input, process, performance, and controls or security mean. Okay. So for outputs, the website must report online volume statistics every 4 hours and hourly during peak periods. So this is one of the outputs that this web-based system should do. Moreover, the inventory system must produce a daily report showing the part number, description, quantity on hand, quantity allocated, quantity available, and unit cost of all sorted by part number. That is an example for output checklist requirement. So this is the check. So this is for the web-based system. So the web-based system must meet these requirements. Likewise, if you are doing a system requirements checklist for a, let's say, a business, a clothing line business, okay, so it will also have some form of output that it should meet. So you are just doing a checklist of that. Now, input, now again, this is from the same web-based example. Manufacturing employees must swipe their ID cards into online data collection terminals that record labor costs and calculate production efficiency. The department head must enter overtime hours on a separate screen. So these are input, examples of input. Next up is the examples of processing or processes. The student record system must calculate the GPA at the end of each semester. As a final step in year-end processing, the payroll system must update employee salaries, bonuses, and benefits, and produce tax data required by the IRS. Okay, so these are some of the examples of all the processes or possible processes the system should have. Moreover, we look at performance. Another example there. The system must support 25 users online simultaneously. Response time must not exceed 4 seconds. And finally, controls. Now, sometimes you'll have it as controls or sometimes as security. They would mean the same thing. The system must provide logon security at the operating system level and at the application level. An employee record must be added, changed, or deleted only by a member of the human resources department. So those are some of the examples of output, input, process, performance, and controls. Now, things to note so far is this: in systems requirement checklist, you should know the 5 general categories. Do make a mark somewhere there or note that you need to know this. You also need to know what are the definitions for data flow diagram and use case. Note it down somewhere, please. Moreover, you should be able to explain JED, RED, and Agile methods. Should be able to explain JED, RED, Agile methods, and the advantages and disadvantages. Those are the important things that you should know so far. Also, please know what is requirements modeling. Yeah? All right, moving on. Future growth, costs and benefits. Scalability. A scalable system offers a better return on the initial investment. To evaluate scalability, you need information about projected future volume for all outputs, inputs, and processes. So when you talk about scalability, you're talking about a system we should be able to offer the same or improve service as the demand increases or decreases. So you have developed a system, okay? Your system is able to support at the very development stage, it is able to support, let's say, 100 users. So after 5 years, your system should still be able to do so, support 100 users, if not support more than 100. Okay, so that's an example of scalability. Now, the only way in which you can ensure that your upcoming project or system is scalable is you need to get and attain information on the future volumes of input, process, and output. That means when we say project future volume, that means in future, what is the most likely situation? So if you are, let's say, running an e-commerce website, and at the moment you assume, all right, there's close to about 700,000 people in Fiji or 800,000 people here in Fiji, out of which you say 500,000 will visit my website to the max in year 2021. Now, let's say you will be running this business for quite some time, and then after 10 years, you cannot expect your system to only support 500,000. What if the number increases? What if the population goes beyond 1 million? So instead of having 500,000 of users, you may have 750,000 users using your e-commerce website. So if you are not able to cater that, and let's say at once you have close to about 750,000 people using your website, what will happen is that your entire system would collapse. So that's why you need to ensure to project your future volume for all inputs, for processes, and output. So, and always please ensure that when you are projecting it, it needs to be an overstated number. For example, in 2020, you can, for example, if you look at the population of Fiji, you can always go and do a data mining on it. So how do you do data mining? Or you can do a simple analysis on it. You can compare it for the past 10 years, see what was the average increase each and every year. So based on that, you can say, all right, this is what the population will be 10 years from now. Okay, so that will give you a projected volume. Total cost of ownership. Total cost of ownership is especially important if the development team is evaluating several alternatives. One problem is that cost estimates tend to understate indirect costs. Rapid economic justification. Okay, don't worry about REJ. Total cost of ownership, that means the total cost that had incurred for you to develop your system and get it fully running. So you are trying to find out what is the total cost of your system or total cost of ownership. Now the formula for total cost of ownership is direct cost plus indirect cost. Now direct cost is like, okay, the amount that I bought the hardware for, the amount that I paid to the staff, the amount that actually took me to develop the entire system. Now that is well catered for. But what happens is, like if you see bullet number 2, what happens is that normally projects or project leaders tend to understate indirect costs. Now, indirect costs, what are those? These would be common overhead costs. Now, if I have to simplify that, overhead cost would be like your rent for the building, the utilities bill that you're paying, electricity, water bill. Now, generally, people tend to ignore these things, but they actually contribute to the cost of the system. How? You're using electricity to run your computers. You're paying rent to have a building. Let's say, even though you are using a existing building, but you are using it for different purpose. So your total cost of ownership needs to cater for all these indirect costs as well. All right, so this is what it's saying over there. Now, fact finding. fact-finding overview. Okay, now when we talk about fact-finding, simple, fact means truth. That means you go and find the truth. Okay, now fact-finding, it is one of the common techniques in which you can go and find out data about the current system. Moreover, you can go and find out what are the requirements or expectations from the new system. So to do that, you need to do few simple things. Okay, first of all, you identify the information you need. Secondly, you need to develop a plan. Okay, so once you've developed the plan, then you need to go and answer these questions: who, what, where, when, how, and why. Okay, so if you're able to answer all this, who, what, where, when, how, and why, if you're able to answer all this by fact-finding techniques, that means you have the valid information with you. The difference between asking what is being done and what could be or should be. Now, this is also important. Why? Sometimes there will be more expectations than what could actually be achieved. For example, if you would go and ask things from a non-technical person, so that person would give you some form of suggestions that might not be achievable. For instance, okay, if I am teaching a let's say, yeah, if I'm teaching a mobile computing based course, and I know this is a very basic level, in degree level that you learn mobile computing. So if I ask you, using your knowledge, go and create an app which is able to run a drone, and that drone is able to transfer blood from CWM hospital to Lotaka hospital. Now, why I'm giving the example is this: my expectation is too high. Okay, because that is technically, first of all, not only it's technically challenging, but that is almost impossible to get it done here in Fiji, because we don't have enough resources. Okay, so likewise, sometimes when you would go to people asking about what things they require in an information system, the expectation would be too high. Now, if you feel that's too high, then you need to give in your explanation there and then. So that's what he's saying: the difference between asking what is being done and what could or what should be done. Now, the first fact-finding technique is interview. This is pretty simple. You know what interviews are. You prepare a set of questions and you go and ask. However, okay, let's go and read this out and see what the proper structure is. You're not doing a simple interview. This is just like a well-established structured interview, which could save a lot of money or which could lead a lot of money into jeopardy. Okay, step one, determine the people to interview. Okay, so you have to go around determining whom do you want to actually go and interview. Okay, whether you will interview the person whom you just like. Let's say there's a friend who works in the organization and you just go and interview them, or would you actually go and interview the people who you feel plays a very great role, or would you go and just interview everyone? That's totally up to you, but you need to determine whom to interview. Step two, establish objectives on the interview. Objectives is what is your goal. Okay, so determine the general areas to be discussed, list the facts you want to gather. So if you're able to establish your goals, okay, or if you're able to meet the requirements, okay, so that's good. If you are not, so you need to go and interview other set of people. So here's the thing: once you reach into step two and you see that upon interviewing the people, you are not reaching the facts that you want together, and the facts that you had gathered, they differ. So you need to go to step one again and then determine new set of people to interview. Okay, it happens at times that sometimes you feel this user would be able to answer this kind of question, but it doesn't actually eventuate. So you have to go back. Step three, develop interview questions. Now this is very important. Okay, that is, when you are developing these questions, what kind of questions should you develop? Create a standard list of interview questions, helps to keep you on track and avoid unnecessary tangents. Okay, so you need to ask, or you need to do the following, or these kind of questions need to be practiced. Avoid leading questions. Now, what are leading questions? When you are asking leading questions, what you're doing is you are basically pushing a respondent to answer in a specific manner. Okay, it's just like your question is based in such a way whereby they are forced to answer something. For example, if I see my brother, okay, he is going somewhere, and I wish to ask him where he's going. So instead of saying, or let's and I ask him where, let's say he has gone from home and he comes back. Okay, so instead of asking where did you go, I might ask him, did you go to a doctor today? So there's a difference. When you say where did you go, those are not leading questions, just a generic question. But when I say, did you go to the doctor today? So that's a leading question. So he has to answer either yes or no, but it has to do in relation to a doctor. So you need to avoid those kind of leading questions. Secondly, your question needs to be open-ended questions. When we say open-ended questions, is just allowing someone to give a free form of answer. Okay, it's just like you ask a question, like for example, where did you go? So that's a free form of answer. Okay, so they can answer in any form. Okay, so if they wouldn't want to tell me something about the doctor, don't say, oh, I just went to town, or I went to just just go and check out a few items somewhere. So those are free form of answers. Close-ended questions. Close-ended questions are whereby you are forcing someone to answer something based on the options that you give. For instance, you will say answer yes or no. So you're forcing them to answer either in terms of yes or no, and you can do that, definitely. You can have in terms of true or false or multiple choice questions. So those are examples of close-ended questions. In fact, generally we are even taught in high schools. If you are making questionnaires and stuff, always try to have close-ended questions. Why? It makes it easy for you to analyze the data. Okay, those are close-ended questions. And then you have range of response questions. So range of response questions is something like multiple choice questions. It's very much similar to close-ended questions, but you have a bigger range. In close-end, it may be just like, okay, yes or no, true or false, or probably one or two options. And a range of response, you may have about 5 or 6, even 10. Okay, so those are range of response questions. Step 4 is prepare for the interview. Careful preparation is essential because an interview is an important meeting and not just a casual chat. Limit the interview to no more than 1 hour. Why? Because it would become boring. Okay, or the other person might just get tired, or the other person may now see what happens is not only the other person may get bored or tired, eventually if they are bored or tired, they will just start answering the question for the sake of it. So the actual essence is missing from the interview then. Okay, send a list of topics. You can also do that. You can send a list of topics via an email beforehand. So what will happen is so that they will be prepared, and ask the interviewee to have samples available. So when you give them a email, or when you send them an email with a list of topics, what happens is generally in some places where you might need text and figures, where you might need graphical data, so you can ask the interview to have some samples available. Okay, and they will gladly bring it. Step 5, conduct the interview. Develop a specific plan for the meeting. Begin by introducing yourself, describing the project, and explaining your interview objectives. Now, step 2 is basically important when you are, let's say, you are a system analyst and you're working for some other organization. Okay, so you are the third party guy over there. So you need to introduce yourself and you need to tell, okay, this is what the project is about, and this is what we want to achieve from the project, and this is the reason why we are conducting this interview, or why you are in the interview with me at the moment. Now, what happens is what happens in that case, it basically builds up the motivation to have it done in the best way possible. And also it gives a sense of agency to the interviewee. Interviewee, the person whom you are conducting the interview to, okay? Or with, rather, conducting the interview with is interviewee. Engaged listening. It's very important. Engaged listening is when two of you are talking, or two or three of you are talking. So the other person, the person who is generally talking, he or she expects the others to listen to them. Sometimes you will notice that when two or three, when you have people talking, so the other person would be either mumbling something in their pockets, mobile phones, or wandering off here and there. Now that would rather be rude. or it may just make the other person very, very angry. So try to engage yourself in listening to what the person is speaking. Allow the person enough time to think about the question. Give them time. After an interview, you should summarize the session and seek a confirmation. So once you've conducted the interview, you should summarize everything and seek a confirmation if they could use the data. Now, if you feel that, okay, summarizing the interview might take some time, it's all right. You can go back. He or she can go back as well. You can come back you can come back to your workplace, or you can come back home, wherever you are. You can summarize the thing and then give out the entire information to them. Okay, this is the summary of the interview, and you can seek a confirmation if I could actually use this with my requirements modeling. If they say yes, you can go ahead. If they say no, and if they say no, they will definitely give you some reasons. And step 6, once they give a confirmation, you need to document the entire interview. Now, why do you need to document it? Because you're developing an information system. You will later on, you have just interviewed one person. You'll not just interview one, you'll interview so many others. So if that is documented, finally you'll take all those documented interviews. Let's say you've conducted an interview for about 30 people. So you will have 30 documents of different interviews. You'll have to compile them together and then analyze the entire data. Remember, analytical skills, okay, and you conducting the interview is interpersonal skills. Now, document the interview. Taking note should be kept to a minimum. After conducting the interview, you must record the information quickly. After the interview, send memo to the interviewee expressing your appreciation. Thank them also. Note date, time, location, purpose of the interview, and main points you discuss so that interviewee has a written summary and can offer additions or corrections, just like I told you earlier. Now, how do you record the information that is conducted in the interview? What you can do is, if your interview questions is in closed form questions, that's easy. Okay, you can just tick. If it's closed form, obviously true or false, yes or no, you can quickly write down. If it's open-ended and then the answers are very, very heavy or very lengthy, now that becomes a problem. In that case, you might either use, you might, or you should learn shorthand writing, like to write it down, or use common day technologies, use a mobile phone to record it up, and after that you can rehear it and then summarize it. Or what you can do is you can just have just like have a Zoom based situation where the camera is open up, and then you can record the entire session. If the person is not convenient, is not comfortable in terms of recording it in form of a video, mobile phone should be fine. And then finally, evaluate the interview. In addition to recording the facts obtained in the interview, try to identify any possible biases. Now, this step 7 is generally when you conduct the interviews for all, you collate all the interviewed documents and then try to find out what have you obtained. Is there any biases, or if there is any confusion, then you can clear it up. Unsuccessful interviews. No matter how well you prepare for interviews, some are not successful. Why? It may be various reasons. Let's say the person whom you are interviewing is in a bad mood that day. He or she doesn't give good answers. Or the person whom you're interviewing is not in the favor of getting a new information system. So he or she would definitely give you answers that will be directly opposite to what you are after. Okay, so some interviews may not be successful. Now, other fact-finding techniques, you have document review. So when you talk about document review, is you have previous documents in the organization. Generally, when you have an information system in the organization, that particular information system would have a document, the user manual, the purpose, okay, how things was done, this and that, okay. So you may always go and read them. Like if there may be more than one, you may go and read all of them and then review the document, or you can assign any one of your project team members to do so, and then you can always go and overlook at those things. Third thing is observation. Observation is seeing the system in action, gives you additional perspective and a better understanding of the system procedures. Plan observations in advance. So observation is just like when the people are walking, you are moving around and seeing how things happen. Now, in this case, it's an IT-based information system, so you cannot move around and look. You need to sit down with them. You need to see how they perform things, how their normal operations go. And sometimes, with the permission, of probably the organization, what you can do is you can record tasks even in their computers. So once they're performing the task, you're recording it, and you can always go and see how people record, how people perform their tasks. So those recordings of it shouldn't be just of one or two people. It should be more than one or two, probably like 15, 20, because different people have different way of communicating or interacting with the system. So you'll be able to find out the best ways people are interacting and what may be some of the flaws. And you have questionnaires and surveys. Okay, questionnaires, I think you should be familiar with what questionnaires are. Questionnaires and surveys, they might have the same thing or same purpose. When designing the questionnaire, the most important rule of all is to make sure that your questions collect the right data in a form that you can further your fact finding. True, this is what we must have learned in high school. When you are doing your questionnaires, always try to ensure that your question is in a form that could be analyzed easily. Now, in questionnaire, generally is suggested to have close-ended, like multiple choice, or most likely true or false, yes or no kind of questions. Sometimes you have a tick kind of options as well. Okay, so in that case, what happens? It becomes easy for you to analyze the entire set of data that you have just collected. If you have open-ended questions, that might make your work very difficult, because in open-ended questions, people have the ability to write whatever they want. Okay, so when they write whatever they want, it becomes difficult to analyze them. Sampling. Now, sampling is more likely you are conducting surveys, questionnaires, or you're conducting interviews based on samples. Now, there are different methods of sampling. The first one is systematic sampling. Okay, systematic sampling would be just like an example of systematic sampling that I could give in very easy way is, let's say you are an FNU Natambua campus. So you are to conduct an interview with FNU students. So what you'll do is, let's say you sit in the cafeteria, and randomly or systematically, what you'll do is you'll go and pick every 10th student who enters the cafeteria. So 1, 2, 3, 4, 10th person comes. Okay, so I'll interview that person, and you go and interview them. And then that person is gone. Then you start counting. Another 10th person comes in. Then you conduct interview with them. So that's an example of systematic sampling. Stratified sampling is like you are again conducting an interview with FNU students. So what you do is you go and select 5 students from each and every course. CIN603, 5 students. Okay, let's say CIN502, 5 students. CIN501, 5 students. CIN707, 5 students. That's stratified sampling. And then you have random sampling. Random sampling is just randomly go and pick any 5 students from FNU. So even though if you are sitting in a cafeteria or wherever you sit, just randomly pick any 5. Okay. And the main objective of sample is to ensure that it represents the overall population accurately. When you talk about sampling, it's more like a statistical view of doing things. So in this case, if you're developing information system in an organization, so you can use either of these methods, or you can make a hybrid method. What is a hybrid method? Is like you combine all these 3 together and then conduct something as such. So you may have let's say every 10 staff from, let's say 10th staff, every 10th staff from the operational level. Okay, and then you have every 5 staff from the stratified level, and then 5 staff using random sampling, something like that. That's a hybrid combination of all. You can do research as well. Okay, research can include internet, IT magazines, books, to obtain background information, technical material, and news about industry trends and development, or site visits. Okay, so just not just within the organization, you can always go and look for external fact-finding techniques as well. So with those external fact-finding techniques, what happens, it generally gives you a better trend of what things are happening, not only within but outside the organization and in the world. And then interview versus questionnaires. So which one would you prefer? So we are given an idea. Interview is more familiar and personal. Questionnaire gives many people the opportunity to provide input and suggestions. Now, if I have to conduct an interview or questionnaire, I don't know, I'll have to evaluate which one is better in which scenario. Now, interview, you will not be able to conduct so many interviews at once. For example, if I want to conduct an interview, I'll have to see not only my schedule, but the other person's schedule as well. So with that case, interview may be more time consuming. Whereas questionnaire, you need to prepare a simple questionnaire and then you can give it out to people. Now, how do you give it out? Through emails. You can have questionnaires nowadays created in Google Forms, or you have another platform, Monkeys, Survey Monkeys. Okay, you can create your questionnaire and then you can forward it to, let's say, 200 people. So whereby 200, you'll have 10 people for interview, you can have 200 people for questionnaire. However, interviews are confirmed things. Once you conduct the interview, you have the information ready in hand. With questionnaire, sometimes people would respond, sometimes they would not. If you have done work with questionnaires, you'll know sometimes you'll have to continuously remind people to actually get it done. And interviews is more personal. It's like you'll sit with the person and then you'll get to familiarize yourself with that person. And then you can, if you are a person with good interpersonal skills, okay, and you are a person with good communicating skills as well, okay, so what you can do is you can, try to be as nice and friendly to them and get the information out of them. Whereas questionnaire is just plain black and white, there's no emotions involved. Okay. Now we also have brainstorming. So with interviews, you can have brainstorming. What is brainstorming? You're thinking something. Okay. Now brainstorming generally comes in two ways. You have structured brainstorming and then you have unstructured brainstorming. Now structured brainstorming is where you try to come up with new things, but it has rules that the participants must follow. Okay. So unstructured brainstorming, it has certain set of rules, whereas structured brainstorming, pardon me, structured brainstorming has certain set of rules. Unstructured brainstorming has no rules, whereby the participants can give ideas and it comes to their mind. Right? Let me repeat that. Structured brainstorming, you have rules involved. So that means participants cannot give in their ideas as it comes to their mind because they have to consider that rule first. Whereas unstructured is like you can give in your ideas as it comes to your mind. There's no hardcore rules associated with it. Documentation. So those were the fact-finding techniques. Now I do not I do not actually would urge you to go and learn all the definitions for this. Just generally know what are some of the fact-finding techniques, and I'm sure you are able to explain what research is, be able to explain what sampling is, what interview questionnaire is. By the way, research here is not the simple copy and paste. Okay, probably with our university, with some university students, their research is copy and paste. No, that's not that's not that kind of a research. Okay, over here you go through materials and stuff, and then do know these things. For example, structured brainstorming and structured brainstorming. What happens is generally it becomes very beneficial. Also know what are those stratified, random, systematic. Those will help in future. Also learn about open-ended questions, closed-ended questions, and so forth. But you do not need to cram, or you do not need to know them by heart. Just know in simple what questionnaires are, what interviews are, what probably sampling would be, what research is, and know that overall, all these are part of fact-finding techniques. Now, documentation, the need for recording the facts. Record information as soon as you obtain it. Use the simplest recording method. Record your findings in such a way that they can be understood by someone else. Organize your documentation so that related material is located easily. So we need to record whatever facts that you gain from any of those methods. Now, record as soon as possible. Why? Because else you might end up forgetting it. Okay, record using the simplest method, which is not a burden to you in terms of costs. Like I said, use your technology. If you have a mobile phone, use that. If you have a recorder, use that. Okay, any form of recording methods, or if you feel you are just comfortable just by writing it down, do that as well. Okay, and also ensure when you are documenting your recordings from fact finding, write it or do it in such a way that someone else may understand it as well. Because if you get sick or if you leave that particular employment, somebody else replaces you, he or she should need to understand. Okay. And some of the tools that you can use to record, okay, or document the fact finding is you can have case tools. It's more of a complicated procedure with case tools. You can simply do it in a productivity software. Example of productivity software would be Microsoft Excel, database, Word, and so forth. Review of logical modeling. At the conclusion of requirements modeling, systems developers should have a clear understanding of business processes and system requirements. So let's say you're reaching the end of requirements modeling. Once you have performed all the work, what you should have is you should have a clear understanding of what the new system is or will be, what will be the business processes in the new system, and what are some of the things that the new system will actually require from the business, from the project team, and from the users. The next step is to construct a logical model of the system. So logical model is just like creating a blueprint of what or how a physical system would function. Okay, logical, something that is not physical. Okay, logical and physical, they are the opposites of one another. When you talk about logical, something in the form of pen and paper, okay, something in the form of documented in a paper, whereas physical is the actual system. IT professionals have differing views about systems development methodologies, and no universally accepted approach exists. Last one, the last point says there's no hard and core specific rule in which method to approach. For example, some would prefer JED, some would prefer RED, some would prefer agile method. So whom does it depend on? It totally depends on the project leader, okay, the project manager. Chapter summary. The systems analysis phase includes three activities: requirements modeling, data and process modeling, and consideration of development strategies. The main objective is to understand the proposed project, ensure that it will support business requirements, and build a solid foundation for the systems design phase. Now, that is the definition for requirements modeling. The fact-finding process includes interviewing, document review, observation, questionnaires, sampling, and research. So these are the generic 6 types of fact-finding techniques. In fact, there are more in the notes, but learn these 6. System analysis should carefully record and document factual information as it is collected, and various software tools can help an analysis visualize and describe an information system. True. Okay, so system analysis need to record it very properly. Why? Because they might forget, or the person who is coming next should really understand it properly. Okay, and also the main reason why it needs to be written properly is so that the person himself, he or she, himself or herself, is able to use the same set of document for the future processes. If the system analysis has not written it properly, so in few days or months or weeks to come, he or she may not understand what he or she actually wrote. So it needs to be documented very, very properly. Okay, so that completes our lecture for week 4. It's 1:20. We are able to finish quite early, 10 minutes before my allocated time. Any questions, any queries, anyone? Now, before you ask any questions or queries, I just want to tell you this, okay? Like I've been mentioning every week, understanding theories on system analysis and design is not simple. The best way in which you can understand it is by reading it over and over again, okay? Or another way is what you do is you go on to the chapter objectives and try to meet those objectives. If you're able to do so, you'll build a good solid foundation in terms of understanding your lectures. And moreover, also note, this is a continuous phase-based lecture notes. In other words, lecture 1 is step 1, lecture 2 is step 2, lecture 3 is step 3, this is step 4. So it's on progressive basis or incremental basis, like we have discussed today in our lecture notes, okay? So it's an incremental basis. Therefore, you'll need to know the concepts over there first, and only then you can jump in here, okay? So yes, everyone, any questions, any queries? We have a class up to anyone? 2 to 4? Do you have a class? Yes. Which course? 707, 705, or 626. Okay. Okay then. So if you have a class or two, so this is where I'll leave you for today. Thank you very much. If you have any questions, queries, you may ask. You still have time. If not now, probably later, then you can always drop me an email or you can drop me a message on Moodle. I'm most happy to answer your question. Thank you, Sammy, for your feedback. So I hope all of you are doing well. Okay, try to keep up with your studies. Also, stay care and stay safe. Lecture quiz, please do make an attempt to go through your lecture-based quizzes. Lecture one, I've seen only 8 of you. Lecture one quiz, there's only 8 of you have attempted. Lecture two, there's only 3 or 4. So please, if you are one of them who are still remaining to it, go and attempt it as soon as possible before things start to load up on you. Okay. If that's it, so no questions or no queries, then we'll call it a day. So thank you very much, everyone, for joining in. See you all on Thursday. Thank you. Thank you, Shannon.